Thanks, Erica. Good evening, everyone. I'm Ruojie Vanessa Zhang. I was a postdoc from Anna Jaklanic and Bob Langer's group and currently work at Reynolds American. This image was taken during my very last experiment before I moved to my current job. It is my big honor to receive this award and share the story behind this image. This project is one of the studies funded by Gates Foundation that aim at fighting malnutrition for humans. The image showed here is a well-designed microparticle that used for encapsulate micronutrients. The green color is a coating material that used for stabilizing the micronutrients and protecting them from heat degradation, which is a common side effect in cooking. The purple color on the outside is starch particles that used for making the microparticle more flowable, allowing it to be incorporated into foodstuffs easily. The basic idea of this project started with Gates Foundation, including Bill Gates himself, recognized that nearly 2 billion people in the developing world are plagued by micronutrient deficiency, which causes up to 2 million childhood deaths per year. Micronutrient deficiency contributes to many disabilities and diseases, including cognitive and physical disorder, anemia, blindness, birth defects, and impaired growth in children. Food fortification is an effective strategy to increase the daily intake of the stable micronutrients. Unfortunately, many of those findings have not impacted the vast population currently suffering from the micronutrient deficiency because of implementation challenges in targeted countries and technical challenges related to micronutrient stability during the storage and cooking. Target population in developing countries consume food products that often require extensive cooking, which introduce heat, moisture, and oxidation, and cause significantly degradation of the fortified nutrients. Therefore, our aim of this project is to develop a microparticle to encapsulate micronutrient in it. When it experiences extensive cooking or storage in hot and humid conditions, the microparticles can keep stable to protect the micronutrients from degradation. Well, when it is ingested, the micronutrients can quickly release from the microparticles in human digestive system. Let's briefly go over how we made this magic happen. We did an in-depth analysis of more than 50 potential polymers and then select BMC as the coating material for micronutrients. BMC is a polymer encapsulant that has historically been used in nutraceutical and pharmaceutical products. And it can form a very compact structure on the surface of the microparticles, providing a moisture barrier and high refractive index surface that can protect the encapsulated micronutrients against heat degradation and UV radiation. BMC also has the properties quickly dissolve at low pH condition. Therefore, the solubility of the BMC enables the microparticles rapidly dissolve and release micronutrients in stomach, which has a high acid condition. The exceptional cooking stability of the microparticles can also be seen in the example of the vitamin A. About 50% vitamin A degraded after only 15 minutes under cooking condition, while this process lasts to 5 hours in the case of vitamin A encapsulated in BMC microparticles. We applied this technology into 11 different micronutrients, and all of them can be quickly released in stomach. The human clinical trial has also indicated that the coating material does not significantly hinder the absorption of the micronutrients. This technology can be potentially applied into food applications such as staple food and bouillon, which are widely consumed in target developing countries and have a high chance to experience extensive cooking. We look forward to translating this technology so that all humans have the nutrition they need for a healthy life. I want to thank my advisors, Anna and Bob, for their support and guidance, and all lab members who work on this project. And a special thank you to David from Nanotechnology Materials core facility helped us to take this image. Last but not the least, I would like to thank Gates Foundation for their funding support. Thanks to all of you for listening tonight.